Hello, my name's Rob and I'm here at the National Space Centre, and today I'm going to cook a comet. Now, comets are best described as giant dirty snowballs. They're found at the edge of our solar system and they're the leftovers from when the gas giants formed 4.5 billion years ago. They sometimes get pulled into our solar system by the gravity of the planets, and we will see them up in the nighttime sky. They're frozen gas, frozen dust, and they often contain very interesting chemicals. So what we're going to do this morning is put together a comet right here on Earth. So the first ingredient for our comet is water. This is to represent the ice that we find inside the comets. Now, not all of the ice in a comet is water. A lot of it is frozen gas. That's quite tricky to come by, but we'll have a look at that in a little while. Next thing I'm going to add is some sand. There's lots of different kinds of rock and dust and minerals found in a comet. So sand being lots of tiny little pieces of rock. We're going to use that to represent our rocks. Then I have graphite. Now, graphite is a form of carbon, and carbon is what all life on the planet Earth is based on. There is a theory that maybe life on Earth started millions of years ago because comets brought these kinds of chemicals to the Earth. But this is an organic chemical, and we're going to put quite a bit of this in because despite being giant dirty snowballs, comets are actually quite dark. We're just going to give it a quick stir just to make sure all our powders have mixed in nicely with our water. And then we're going to add our secret ingredient, Worcestershire sauce. Now, that might sound a bit of a strange one, but Worcestershire sauce is actually made using anchovies. Anchovies are fish. Fish have DNA, and we also think that comets may have brought amino acids, which are the building blocks for DNA, to the planet Earth. So then we have our fish DNA representing our amino acids. So we've got a nice mix of water, graphite, sand, and Worcester sauce there. Looks kind of like mercury at the moment, but it's still very warm. We need to get that cold because space is incredibly cold, and also these comets contain frozen gases. So to represent those frozen gases, we're going to be using dry ice. This is solid carbon dioxide gas, and this has quite an interesting little feature. Dry ice doesn't melt. It changes straight from a solid into a gas form. Now, that is called sublimation, and exactly the same thing happens with a comet in space. That creates the tail that we see around the comet, which is the bit we can see from Earth and probably the most well-known part. So we're going to add that to our comet. This is to make sure that our water, sand, graphite and everything else gets nice and cold. And you can already see sublimation happening. This is the very cold -78-degree dry ice being warmed up by the water, and as it sublimes, it bubbles up through that water and starts to cool down the water vapor in the air around us. So although this looks like smoke or fog, in actual fact it's the same kind of thing that we have in a cloud. So what we're going to do is squidge all this together. Before I do that though, I'll just hold the bag close for a second so you can see. That's the carbon dioxide gas from the dry ice filling up the bag, a bit like a balloon. But we need to let that out, and we need to get everything a really good squeeze together to get it to freeze. Okay, feels like our comet might be ready. Let's see what we've got. So there it is. A lump of ice, water, graphite, sand, and organic chemicals. Now, real comets are hundreds or even thousands of kilometers across. This one's only very small, but it just gives you an idea of what's contained inside a comet. And maybe next time there's one flying through the space near planet Earth, we'll be able to go and see it.